6-2, solving systems using substitution. So our objective for this section is to solve systems of equations using substitution. Our essential understanding is that systems of equations can be solved in more than one way. When a system has at least one equation that can be solved quickly for a variable, the system can be solved efficiently using substitution. So we can solve linear equations by solving one of the equations for one of the variables. Then substitute the expression for the variable in the other equation. This is called the substitution method. So in 6.1 we saw how to solve a system of equations by graphing both of the lines and then seeing where they cross. That is an okay method because if your graph is wrong or if it was a hard equation to graph, then you might not get the right answer. However, with the next two methods in this section and the next section, we can see how to solve these systems algebraically. So the first method is, of course, the substitution method. Okay? And what we're looking for here is we're looking for one of the variables or one of the equations to be solved. Okay? What do I mean by that? Well, take a look at this equation. We have y is equal to 3x. Okay? That equation is solved already. One of the variables is isolated. One of the variables is by itself. Now, because I know that y is equal to 3x, okay, I can use that information to help me solve this next equation. So x plus y is going to be equal to negative 32. Well, I can't solve that because it has two variables. But if I use this information right here, that y is equal to 3x, I could get rid of the y and put something that is equal to, which is 3x. Now look what I've done right here, is I've made an equation that only has one variable. And when you are able to do this, when you can make an equation with only one variable, you can solve it. And we can solve this pretty simply. 3x and x gives me 4x is equal to negative 32. Divide out the 4, and we get that x is equal to negative 8. Now, of course, we're not done yet because remember what we're looking for. We're looking for the place where these two lines intersect. And the place where two lines intersect is a point. So now that I have x, I can plug x back in to either equation, but the top one happens to be a little simpler. And I can say that y is going to be equal to 3 times x, which is negative 8. So y is going to be equal to negative 24. Okay? Which means the point at which these two lines intersect is going to be x comma y, negative 8 comma negative 24. Let's look at it. Let's look at a got it problem. Use substitution. Well, now y is equal to 2x plus 7 and y is equal to x plus 1. So y is going to be equal to 2x plus 7 and also y is equal to x minus 1. X minus 1. Okay. Well, I know that because these are both equal to the same thing, I can use substitution to replace y with something else. Let's replace this y right here. So I can, instead of y, write that x minus 1 is equal to 2x plus 7 because x minus 1 and y are the same thing. Subtract x from both sides to give me negative 1 is equal to x plus 7. And subtract 7 from both sides to give me that x is again negative 8. Right? And then I can plug it into either one. The x minus 1 looks a little bit simpler. So I'm going to say that y is going to be equal to negative 8 minus 1, which is y is equal to negative 9. And my answer as a point is negative 8 comma negative 9. Okay? To use substitution to solve a system of equations, one of the equations must be solved for a variable. Okay, so what we're going to do is we're going to look for the variable that's by itself. If there are no variables by themselves, then we're going to have to use a different method, which we'll see in the next section. Okay, so when I look at these two equations right here, okay, my choice is to solve it. There are a few, okay, but because I noticed that y is by itself right there, I know I can use substitution if I want to. Let's rewrite that equation right there. So it's negative 2x plus y is equal to negative 3. In order to use substitution, the variable must be by itself. So I have to get the variable by itself. And I'm going to do that by adding 2x to both sides, which gives me y is equal to 2x minus 3, because I cannot put those together. Now I know what y is equal to. So now I can take my other equation, 3y plus 4x is equal to 14, and I can replace y with those numbers right there, because y is equal to 2x minus 3. So I can say that 3 times 2x minus 3, which is y, plus 4x is equal to 14. And now this is just a matter of solving for x. So let's distribute. 6x minus 9 plus 4x is equal to 14. That's 10x minus 9. When I put these together, they're on the same side, so I can just add them together. Is equal to 14. Add 9 to both sides. 10x is equal to 23, which makes x 2.3. Is it okay that I got a decimal? Yes. Okay. Systems don't always have to give you perfect numbers. Okay. Now, of course, we're not done yet. And I have y is equal to 2x minus 3, just plug in x. So y is going to be equal to 2 times 2.3 minus 3. Remember to multiply first. So that's going to be, whoops. No, that's right. Okay, so 2 times 2.3 gives me 4.6 minus 3. And y is going to equal 1.6. Now I didn't have to plug it into this form of the equation right there. I could have plugged x in there. I could have plugged x in there. It doesn't matter. But I have y all by itself already. Okay, so plug it into the one that's a little bit easier to manage. Okay. So what's the solution to the system? Use substitution. And in your first step, which variable did you solve for? Okay. So when I look at this, 6y, 5x, 3y, and an x by itself. So the easiest one to solve for is probably that x by itself. Now, I could get this y by itself by subtracting 5x and dividing by 6. That's going to give me fractions, okay, or decimals. Not the best idea when you're trying to solve these systems. So, look for the letter that is by itself. The x is by itself, get x equal to something. Okay, so we have x plus 3y is equal to negative 7. Subtract the 3y from both sides, and we get that x is equal to negative 3y minus 7. Then replace the x in the other equation. That's very important. Don't replace this x with 3y minus 7. Okay, replace the x in the other equation. So it becomes 6y plus 5 times negative 3y minus 7 is equal to 8. And now I have an equation with only y's. That was the point. Okay? So 6y minus 15y as I distribute this gives me a negative 35 is equal to 8. 6 minus 15 gives me a negative 9y. Add 35 to both sides, and we get 9y is equal to 43. Divide out the negative 9, and we get that y is equal to negative 9, negative 4.8. We'll round up. Okay. Now that I have y, plug it back in. So x is going to be equal to negative 3 times negative 4.8 minus 7. Which gives me that x is equal to 7.4. Again, write your answer as a point, which is 7.4 comma negative 4.8. And that is the place where these two lines cross. You can do the same thing for a word problem. Okay? So a snack bar sells two sizes of snack packs. A large snack pack is $5. Small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs does the snack bar sell? Okay. Well, if we call the large one X and the small one Y, right, we know that together we are going to sell 60 of them. Now let's deal with the money. Large snack pack is $5 plus small snack pack is $3, which gives me $220. Okay. So now for this problem, I see x is by itself, y is by itself. Okay. So let's solve this equation for one of them. Well, let's solve for x. Subtract y from both sides, and I get that x is equal to negative y plus 60. Then, plugging it in for x, I know that 5 times negative y plus 60 plus 3y is going to be equal to 220. That's negative 5y plus, plus 300 plus 3y is equal to 220. The y's can go together, so that's negative 2y plus 300 is equal to 220. Subtract out the 300. Okay. Negative 2y is equal to negative 80. And if I actually got a negative answer here, I'd have to go back and check because that wouldn't make sense because I'm solving for the number of snack packs the snack bar sold. So divide both sides by 2, and I get that y is equal to 40. Okay? And because I solved for y, which the question said small snack packs, and I made the small snack packs equal to y, I'm done. Okay? I don't actually need to go back and plug in for x. Now, if I had solved for x, then I would have had to have one more step and solve for y. And in case you wanted to know, they sold 20 of the large snack packs. Let's look at a guided problem. You paid $22 to rent 6 video games. The store charges $4 for new games, $2 for old games. How many new games did you sell? So let's call that x. Let's call that y. Okay. So we got, oh, whoops. In total, let's get rid of these. In total, we got 6 of them. So x plus y is equal to 6. And then 4x plus 2y is going to be equal to 22. Okay. So now, I want to know how many new games I rented, which means that I should get y by itself, because then I can replace it for x. Watch. So if I have x plus y is equal to 6, subtract out the x, I know that y is equal to 6 minus x, or negative x plus 6. Right? Now, when I plug this into my equation for x plus 2, 6 minus x is equal to 22, I'm now solving for x, which is the number of new games. Okay, so if you're able to isolate, or if you're able to give you an equation that has the variable that you're looking for, you only need to solve this once. And we do that by isolating the variable that I'm not really looking for, so that way the only letters that are left over x is the one I want. 4x plus 12 minus 2x is equal to 22 after I distribute the 2. Right? 4 minus the 2x, they're on the same side, so they just go together. It's 12, 22. Subtract out the 12, and I get 2x is equal to 10. Divide by 2, x is equal to 5. Okay, so you are going to buy 5 new games, 1 old game. If you get an identity, like 2 is equal to 2, when you solve a system of equations, then the system has infinitely many solutions. If you get a false statement, like 8 is equal to 2, then the system has no solutions. And we can see this when we try to replace and solve this equation, when we try to substitute. So x is equal to negative 2y plus 4. So we can have 3.5 times whatever x is equal to plus 7y is equal to 14. Okay? Distribute gives me negative 7y. 3.5 times 4 is 14, plus 7y is equal to 14. The negative 7y and the positive 7y go away, which means I have 14 equal to 14. Okay? This means that we have infinite solutions because we have something that is true. So that means x and y could be anything, and we will get these two sides to be the same. Why does that work? Because it happens that these two are the same line, right? These two lines are on top of each other, so where do they intersect? They intersect everywhere. And the opposite for these two is that if two lines don't intersect, they're probably parallel. Let's try. Y is equal to negative 3x minus 11, so I can replace y with 3x minus 11. And those cancel out. Negative 11 is equal to negative 13. Which means that no matter what solutions we pick, we're never going to be able to get these two lines to intersect. Okay? Because they are parallel. How many solutions does this one have? This one's a little trickier because notice that none of the variables are by itself. Okay? So what we're going to have to do is maybe make one of the variables by itself. So I'm going to have to use division. Or I could notice that if I rearrange this and look at this, 3y plus 2.5x is equal to 4, which was the bottom of equation, just written in a different order, I can see that if I compare these two, if I multiply this equation by 2, I'm going to get this equation. And if we have the same equation, they will have infinitely many solutions. If I want to solve this by hand, I'm going to have to divide everything by 2.5 or divide everything by 3 to isolate one of the variables and then solve it that way. Okay, but this one has infinite solutions. They are the same line. Okay, so for our lesson check, solve each system with substitution. So This one is not going to work out very nicely, but I can just plug in y right there, or uh, plug in 4y for x. So we have 3 times 4y minus y is equal to 70, which means that 3 times 4y minus y is equal to 70. So 12y minus y is equal to 70. 11y is equal to 70, so the answer is going to be 70 over 11. Okay, of course that's y. Solve for x. Okay, here y is by itself. Okay, here we can see that if we were to rearrange this, that there would be no solution. So let's look at number 3. Okay, so y is equal to 2x plus 1, which means that instead of y, I can write 2x plus 1 is equal to 6. So 4x minus 4x minus 2 is equal to 6. No solution. The other way that I can do this is I can look at y. If I move the 4x to the other side, I would get negative 2y is equal to negative 4x plus 6. Well, I want y to be positive, so that would be 2y is equal to 4x minus 6. And in order to compare these, I want to get y by itself, so I'm going to divide everything by 2, so y is going to be equal to 2x minus 3. Y is by itself, y is by itself. 2x minus 3 plus 1. These lines have the same slope, but different intercepts. They are parallel. Okay? Same slope, same intercept, same line, different slopes. We are going to get one answer. Okay. Number 4, if you want to work that out, is going to be no solution as well. Let's set up the equation for number 5. In a talent show of singing and comedy acts, the singing acts are 5 minutes long, comedy acts are 3 minutes long. The show has 12 acts and lasts 50 minutes. So it means both acts together give me 12. Singing, 5 times x, plus comedy, 3 times y, is going to be 50 minutes. Okay? And I can solve this just like we were solving any of the other ones. Isolate x or y, doesn't matter. Or, yeah, they asked for both, so it doesn't matter. We're going to have to solve them both. And solve, and you will get 7 singing and 5 comedy. 6, when is the substitution method a better method than graphing for solving systems of equations? Graphing can be inexact, so solving for a system is usually better. And it's also difficult to sometimes figure out where the intersection is, especially when there are non-integer solutions. Okay? The substitution method is usually better because it can always give you an exact answer. Okay? Graphing is more to demonstrate our solution instead of actually solving for the exact solution. For each system, tell which equation you would use to solve for a variable in the first step of the substitution method. Y is by itself there. Y is by itself there. Okay? Those are where I would start. I would isolate that variable, the variable that's by itself. And then finally, tell whether each statement is true or false. When solving a system using substitution, if you obtain an identity, the system has no solution. That's false. An identity means you have the same thing on both sides, which means that the system has all real numbers as a solution. And you cannot use the substitution to solve a system that does not have a variable with a coefficient of 1 or negative 1. That's false. You can do it, but it's probably harder and not as efficient as the way we'll look at in the next section. And this is 6-2, solving systems using substitution.